Interactive experience. I'm going to talk about some security. I'm going to do the device-to-device integration introduction again. Has anybody seen that before? The whole read-read thing and integrating devices to robots? I think people have seen it. So anyway, if you haven't, maybe repeat for some people. I think people know who I am, so I'm going to skip over the next slide. I don't know who I am. So, yeah, Will Sobel. I do stuff with MTConnect, analytics, and things. So I'm going to talk about simple security. I'm not going to talk about cybersecurity. Sorry. I think you heard a lot about cybersecurity yesterday. So this is just how, because people keep asking me, is the MTConnect agent secure? And it's not really, but it can be. So how we're going to make it actual, put some security on top of it quickly. So does it support HTTPS or encryption or authentication? And the simple answer is no, it does not. The agent does not support this. But guess what? We can do it. Because we can actually add things like, does anybody here know about nginx? OK, 1, 2, yeah. nginx is very popular. It comes out of Russia. Caviar, borscht, other things. It's been the sweetheart of a lot of it's probably one of the fastest growing adoptions. And what I really like about it is super fast, especially if you put it onto a Linux platform. It is like blazing fast. And it uses some very nice low-level evented APIs, which cause it to fly. And the other thing I really like about it, it is much easier to configure than Apache. And when you're doing one of these presentations in front of a lot of people and you want to configure something, you really don't want to use Apache. But Apache is really good too. So what we need to do to be able to do this. So I'm going to show you in a few easy steps how to create certificates for nginx, so how to basically enable HTTPS on nginx in about 5 steps. And usually we're going to create a certificate locally. But the deal is, usually you'd go to some kind of root certificates authority like VeriSign, GoDaddy. You can buy one of these things. It costs you maybe $100, $200 if you want to get it really authenticated. And then they do a little bit of a background check to make sure that you are who you say you are. And depending on what level of security you want to get, that little green bar that you get when you go to a secure site? Anyway, that is because it has a root cert that is coming from a known authority, certificate authority, that has signed that certificate for you. And you are now, it is attached to usually an IP, and you are that person. So they have verified everything for you. So that's why sites are secure. Anyway, we are not going to do that because we're not paying anything for this. And we'll just generate one. And this is going to work. This demo, I'm doing it on my Mac because I was downloading Linux, but it was going to take about 12 hours on this network, so I didn't get it installed. So no Ubuntu. But I'll do it on my Mac. It's basically the same deal. It'll work on any of the Starnix platforms, so Mac OS, FreeBSD. Whatever on Windows, I don't know. I haven't done it on Windows. I guess possibly Cygwin. Anybody nodding? Anybody know?
Yeah, somebody in my life is
OK. Cygwin. So you can do the same thing on Cygwin. It's pretty easy to set up. First thing we're going to do is create a certificate. So basically what this very simple little command here that you see is an open SSL is a command line utility which creates a certificate, and it's an X509 certificate. We're saying it's going to last for 1 year. It's an RSA 2K size. We're going to generate a key and assert. You need both pieces, keys and certs. And I could type that command, or else I can just show you the output. It has been here a long time. I'll just, what the hell? Let's go for it. So just cut and paste it. That's going to ask you some embarrassing questions, like what country you're in, two-layer code. The state or province, we're in Texas, last I checked. Still here? Okay. City, Dallas, where JFK got shot. Anybody else go see the X? Let's see. The organization name will be MTConnect. MTConnect. That's just a section. I don't know. Let's say, yeah. That's our department. Put MTConnect here too. Email address. And that's it. Very hard. So you just type that command in. It creates two files here. There is a nginx.assert. Looks like that. And a key. And what these are, when you get like a root cert and you sign it with nginx, with one of the root cert authorities, you'll get what's called a cert keychain, which goes, or a cert chain, which goes all the way back to the root authority. And basically, one guy signs another guy, and that gives you the authorization to, it basically authorizes you to use that certificate, and it gets tracked all the way back to that original authority. Encoded in this is actually information about your organization and all that junk, as well as root cert points back to the place that you can actually do verification of the whole thing. So it's what everybody uses. Lots of fun. So now we have our certificates. And we'll go back to my slide deck here. So that is step 1. And we just did this step here where we put all of our information in. The next thing we got to do is configure our server. So what we're doing here is we're basically saying that this is inside of the nginx configuration. So there's an nginx.conf file I'll show you in a second. And we're saying we're going to listen on port 443, which is the HTTPS port. And we're going to use SSL, Secure Socket Layer. And the server name for us is just going to be localhost because we're not being fancy. And this is the location of our certificates. Now, user local etc, usually it's in /etc on Linux, but I installed it on my Mac, so it's using brew, so that's where it is. Most people don't care about what I just said. So anyway, these are the locations. Just has to point to where that file is within the file system. And that's most of it. And then the session cache and session timeout are here. 5-minute timeout, where to cache it, 1 meg. And then down here is the other magic, which basically says for every request that comes in, location / means for everything under root. Do proxy buffering. We're not going to do any proxy buffering for this guy, but we are going to pass. The proxy pass is the whole trick. So what this says is any request that comes into nginx, just pass it back to this location. So basically, it just forwards this request from here to this URL here. That could be anywhere. And basically, this little trick here hits the agent. So when I come in under HTTPS and I hit my server, it will automatically take the rest of that, URL and just shove it back over there.
Hey, Will,
Yeah.
are you relying strictly on like firewall to block 5,000 from getting access directly?
Yeah, on this machine, it would have a firewall on it. So if I was going to configure this whole machine for security, I'd only have port 443 open. I'd turn off ICMP. I'd turn off all that stuff.
But that's the only thing that's blocked.
Yeah, so I'd only open 443. All the other ports are blocked. So to the rest of the world, this machine would appear invisible except for port 443. And so you'd only be able to hit it with HTTPS. So that pretty much locks you down. You may want to have like port 22 if you're doing SSH into it for maintenance commands, but that's also going to be certificate based. You can even lock this thing down more, and I'll show you in a second how to do that. So let's do a little bit of nginx configuration. And I might, because it's been a long day. So bigger so everybody can see nicely. This is the default nginx configuration file. It, by default, comes up with listen on port 8080, localhost, location, HTML, and everything else, and error pages and so forth. But you know what? We don't want any of that. So I'm going to turn a couple of things on. First off, you can turn compression on, so it'll automatically compress things. Ain't that fun? Agent doesn't do that, but if you want to have compression, you can have compression. I'll put the logs in a second. Let's take those from this other file. I have a cheat file, so you don't have to watch me mistype a lot of things. Also, worker processes, you can crank that thing up if you expect a lot of load on this guy, but I think 1 is usually enough.
So, Will, I'm curious.
Yeah, sure.
Are you using this sort of as the default now, like when you're doing implementations, or do you only pull this out when people really request security? And how are you sort of framing?
We've never done this, actually. But there's no reason not to. I mean, it's pretty straightforward. And if somebody did come back to us and say we wanted to create a secure environment, this is exactly what I do.
Okay.
So I'm going to pull out, so this is the default configuration. That goes away. I got just this. And we have the little, they commented out a little thing here for you to use to figure out how to do this. But what I'm going to do is I'm going to pull this guy out as well. So I'm just going to let my stuff go here. And we're going to just configure up this guy here. So we're, this is the listen statement. And we're going to replace those with the ones from the other in 2 seconds. So change the proxy path. Oop. You can also serve up the files directly from this, which would be more efficient, most likely, for things like, and then let's take the cert lines here too. So this is our certs. There we go. So these are the certificates. We just configured up, and we're going to do proxy pass, just like I showed you, and that's done. So now, oops. Yes, it is a duplicate. You can do things if you're typing like I am. You can actually do a nginx -t to test it, to make sure the syntax is okay. Type nginx and just hit return. It will actually look like it does nothing, but it is running in the background. And then, if we pop back to our site here, now, what you're going to see here is this little red X that's going to say, oh no, you're running something horrible. And it says, proceed to localhost unsafe. Now, it's going to say bad gateway because I haven't yet started the agent. So I need to do that. Now the agent is running. And so there it is. This is using HTTPS. Now I got a secured, basically encrypted communication stream to my agent. But you may say, that is not really secure because you have no password on that. So, the only way to actually authenticate. So, we can actually create a password. So, the basic auth, basically when you make a request to a server and it pops you up that little obnoxious pop-up saying, please type in your username and password. We can do that with nginx as well. So what you first have to do is create a password file. And let's see. That is done like this. So let me go back to my other window. Why is it there? Okay. So all you gotta do, so OpenSSL, standard thing you can get in Cygwin, or it comes on every Unixy flavor known to man. And then I'm just going to create a password. So dingo. That's going to create this thing here. So if I look in my, and then I'm going to put that into this HT password file. And the HT password file basically is just a name, colon, and a password. This is actually the same password, but the password actually creates what's called a salt in front. It's supposed to make it a little bit harder to crack. You can also use other types of passwords like MD5, SOM, secure, SSH. There's more secure ways of doing this. This is the cheap and easy way because I'm being lazy. But this thing here basically is all you got to do. It's just name, colon, password, as I have in my presentation here. So then what do we got to do? So we just have to go back to our little file here and nginx.conf and go down to our location. And then type these two magic words. And basically what we're doing here is we're saying that we're using what's called basic auth, which is one of the simplest forms of authentication. There's others too. And then, here we can call it even secret agent. Okay, so that's our secure agent. And then we're pointing it to the basic user file. So auth basic user file. Full path of that guy. And we go ahead and, oops. Keyboard's kind of screwed up right now. And then we just do, you can actually do single stop. Fire it off again. Now let's go back here and now the pop-up comes up. Now I type will, my super secret password. I get to log in. No, it worked. So, and it caches the password, so it'll work again. I probably should have done something in between, but actually it does work. And if you see it from the command line, let's go through the whole thing here. There's also command line tools you can use to be able to access it. So, back to my presentation. Is anybody familiar with the curl? The curl utility? This one? Yep. Okay. There's also libcurl, which I'm going to show you in a second too. So curl allows you to make HTTP requests against a server. And I'll explain what these mean in a second, all these things. So that's basically all I got to do. And type your password in. So let me pop this guy up a little bit so everybody can see. I'm just going to do this here. You're going to see what's going to happen. Now it's going to give you this error. What this is telling you is that this is not a secure authorized certificate because guess what? We just created it locally. So it's not been validated by a certificate authority. It's going to say, I do not want you to do that. That is what the -k command does. It says, OK, fine. Yeah, we know it's not secure. We're still OK. Then, if I try to go again, it's going to give me this error here, which is a 401 error saying, sorry, we cannot authenticate you. If you look at what's going on verbosely, -v is very useful if you're trying to figure out what's happening in libcurl. Basically, it's going and sending this request over, get, so forth, agent accept, And what it's going to send back is a 401 unauthorized. It says that you're not allowed to do this. And the realm is secure agent. This is actually exactly what happens when you use a browser as well. So how do we get around that? Well, we got to tell curl that basic auth. And make it me. Our super secret password. And now it works again. And if we look up at the top, we can see what happened. So what we're doing here is, again, it encrypts mildly the password when it sends it over. Just basically the same password style encryption, standard Unix style encryption with the salt in front of it. And then it says to accept it, and it does a comparison there. So basically, we connect, it tries to connect, connection refused, and it connects again to localhost, and starts a TLS, which is a secure sockets connection. Server verified, MTConnect. That was, remember, in our cert. And then it says server auth using basic with user will, and sends over the authorization basic with the password. User agents curl, everybody's happy. Now, and it sends it back, and that's all your data. Now this can also be done programmatically. So if you're doing programmatically, like in C or whatever, libcurl I think is in many different languages, you can set this thing up. So if I wanted to do it in like the, this is a C streamer library that I got here, I would go to where I set my options, right around here. Yeah, it's small. Exam here. And I would set my options and then put into those options the username and password, and then set it up to use HTTPS. It's all built in automatically to libcurl, so curl knows how to do this. There's already libraries for this also in C#. The standard C# library also has a similar way of being able to say use HTTPS, use these authentication parameters. It's all the same basic thing. I can show you that if you want to. In the other, this is actually on GitHub MTConnect C stream. We have a couple of these examples in the MTConnect. So we talked about them a little bit before. That's why I decided to kind of pull them up. Let's see. Where is it? There's actually a lot of stuff up here. So this is actually in C#. So the real-time piece is where it pulls, actually does the pull. And you can set it up. There's a security settings, and there's various different things you can do to basically configure this guy up as well. I have to find it. But if somebody's interested in this, I can throw together an example and basically show you how to do it. The request is set up here, the web response. And into the request, you can set a number of different options regarding security and so forth. So if you want to take a look at this code, again, this is up on GitHub, and play around with it. If somebody's interested in doing this, I can work through some examples and put it up. Are people interested in it? Guess no? Nobody interested? Somebody interested? Going once? Oh, Dave?
Yeah.
Okay, one person.
Don't just do it for me, Will. I know you wouldn't.
Yeah, so I'd do it for you. Dave, come on.
No, you've
Yeah.
done it. You've done way too much already, so I should pull my hand back.
No, I mean, I'd be happy to show people how. But that's, so in sort of the short answer is, to be able to secure the agent and do this, either programmatically for programmatic access or for even just straight access, it is pretty straightforward. And using nginx as your sort of gateway or your reverse proxy server is extremely efficient and will work with MTConnect perfectly. So, you know, if somebody asks you, is MTConnect secure? The agent itself doesn't have security built into it, but it's easy to add. Whenever you're using tools for developing websites like, Rails, Django, or let's say Node or anything like that. Those don't have security built into them either. They always expect to have some kind of a web server front-ending it that will provide that security for it, and they sit behind that, and then they provide the access and the fault tolerance and everything else. And maybe we can add that to MTConnect Agent next version as well, so we can have a very robust solution. So anyway, that is part one. Yes?
Have you done any performance analysis to see how much extra overhead you need to do encryption?
No, I don't. I haven't. But I know that nginx is probably the most efficient out there right now. And yeah. It supports public private key. It supports. You can really configure it up to have lots of security. Yeah, you can. There's a different. I don't know how to do it exactly, but I have seen it. So yeah, you can actually do a public private key. It supports full SSL and everything else. Yeah. So I mean that's probably your easiest way to be able to quickly implement a secure agent. And I was talking to some people about even if they want to throw it on like a little hardware device, like a little embedded computer. You can pop nginx on that as well, and now you have a secure device, and then you can only have like 2 ports open, SSH, port 22, and then port 443, and you have a very secure data platform, and then with passwords, or you can do dual cert, you can actually have something that is extremely robust.
Did you whitelist in this case for the adapter, did you basically just whitelist the IP of the agent machine and lock down all other machines from contacting the adapter? Is that how you locked it down?
I didn't even, no, for this example,
You didn't do
I didn't do anything. I was trying to make it like super simple. All I did is just said that we're going to be using this certificate, and then I said that we're going to be using this, proxy path, basic auth. So it's like a simplest form of authentication. There's a bunch of other more complex forms of authentication, but then I'd have to create more certs. And public keys, private keys, I'd have to do whitelisting, and you can do any of that with nginx. I'm just, for a demo, I thought. Considering I did it like this afternoon. So, yeah,
I
so.
want to make sure that the agent is hitting the nginx server, and the nginx is like forwarding
You got it.
the adapter.
Yeah, so going back to this, basically this line here, Proxy Pass, says whatever I get here in this server, anything under this, pop it down to there. It's a bit more complicated in Apache. You have to use the URL rewrite engine and turn all that stuff on and then use patterns. At least you used to when I was doing it years ago. Nginx, one thing I really liked about Nginx when I went over to Nginx from Apache was just it was about 50 times simpler to do this. And then in Apache, it seemed like I was always writing thousands of lines of pseudo XML. And this thing was just like you write a couple of lines and turn it on, and it just basically works. And as you saw, I'm pretty tired right now. So I was able to type this without screwing it up too much. So it's pretty easy to do. It's very reliable, super fast, super efficient on Linux because of the way they've written the internals of it, using events instead of using multiple threads and workers. Basically, they've scaled this thing out. It is blazing. And these guys are all about efficiency and about performance. So it's a great little guy. Yeah?
What kind of server-side scripting does that support, do you know?
Basically, the way it works, again, it doesn't do server-side scripting or CGI. It's not really meant. I think you can set up CGI, but nobody does that anymore because it's really nasty. Basically, every application I've seen that runs with Nginx with application functionality behind the scenes is using Proxy Pass, and they're even getting into. I don't know if they got anybody know if they have what the hell is it called? WebSocket support yet, fully implemented. Before it was a little bit of a problem, but I think they were working on it. That was about a year ago. They may have it already working. So basically what that allows you to do is set up a full WebSockets connection all the way back. But there's a whole protocol for how that has to be escalated and everything else. So
I don't really know. Are you guys looking to do WebSockets in the standard eventually?
I'm looking at using multi-protocol. So hey, if somebody wants to implement it.
Since nginx 1.3.
Yep. Yeah. So yeah, before it was a problem because when you're doing a proxy pass to the back, you have to basically elevate that connection up to a WebSockets connection and then do the reverse connection and then kind of pass that whole state back and forth and maintain that connection. It's somewhat complex. I know they were working on it. There was like a beta, and it would just blow up in your face horribly. Now they seem to. That's great. So yeah, so we're thinking about doing multi-protocol next version. So yeah, things like Stomp and everything else. If somebody wants to implement the emitter for the agent for that, we're happy to support you and work with you on that. We may not do it ourselves, though, this time. We want the community to help. So any questions on that? So we have security now. So now when you want to hook up your interface. So interfaces, everybody familiar with what this is, an MTConnect concept? No. OK. Has anybody ever heard these words put together like this? So, OK, intent-based orchestration is a new buzzword that seems to sound really cool. And because nobody knows what this means, you can even sound cooler. So the idea is intent is one of the new buzzwords that's flying around in a lot of different areas in the industrial internet space. Networking, there's security, there's design, a whole bunch of different areas where you're starting to use this word. What it means, sort of in layman's terms, is the idea that you can express a higher level of request. You're not going to the low level. So if I'm telling a robot, to begin a cycle, which has, like, it's telling it to then say, OK, move to this position, open your gripper, move to that position, close your gripper. But I'm expressing my request as a series of operations, and so the low level, that's not really an intent-based. What we're talking about is intent, is I want to express it as a high-level meaning. I want to say, I need you to load material in. I'm a machine tool. I want you to load material into me. I don't want to get down into the details of how you do that. I don't even care how you do that. It could be a robot. It could be, a German Shepherd, very highly trained German Shepherd. But we don't care. We just, for the machine tool side, it's saying, I need this thing to be done. And some device out there is going to take this action and do this activity. What it means also is that how that activity gets completed is not also something that is defined. In other words, if, let's say, loading material, a machine needs the material loaded, if that requires, let's say, the robot to go off and fetch some material and come back and then put it in the machine, it can do that too. So the activity, the actions that are required to be able to complete a process or complete something are defined by the device. So you're talking about distributed intelligence and moving the intelligence out to the edge. So the other thing that this brings when you start going into these types of communication protocols and more intent-based is you can get rid of a lot of the intermediaries, cell controllers, and other PLCs and other things, because you're talking at a higher level and you're talking using communication standards. You're not talking in little bits and bytes. You're basically communicating these high-level commands or requests, and it tends, once you get rid of a lot of this junk here, it gets a lot cheaper. So cell controllers usually very expensive. Then you have a whole bunch of PLCs that are implementing various different custom interfaces, and then those go out to the controllers, and there's usually a bunch of wires running back and forth, and it's all going through the central place, even though for multiple different devices. So the idea is you simplify this architecture down here and just have these two guys talking directly to each other, and things work a lot better. And so there's now more research going on in this area. Look at it a different way. Again, now we just did security, so instead of using, let's say, insecure HTTP, let's say you wanted to make sure that these guys were communicating securely. Well, now you can just say, okay, put certs on them, so you have to be authorized to be able to communicate to these devices. Now, control and the executive here are communicating back and forth. And there's safety involved in this because basically if the devices are intentional or they have intelligence, then you're not instructing them to do something, you're asking them to do something. If they can't do it, they just won't do it. So there's the assumption that the devices have some level of self-preservation and they will protect their own safety. So it's a better way, we think, of doing this. Oops, that got duplicated. So it's basically removing the intelligence in the center and pushing the intelligence out to the edge. Again, what we're trying to do is get rid of this type of an interface. So this is actually the interface from 2014. I'm going to put these slides together, which is the way that usually robots are integrated with machine tools is you hook up like a bunch of pins, and each one of those pins corresponds to a different function like open door, cycle start, unclamped, clamped, and so forth. And that's how it's communicated. And of course, they're just binary state of 0 and 1. What we want to be able to communicate is rich data that talks about what part it is, what the whole information model, the requests, what the state of the request is. So here's a material load request that is in an active state. Unload is unready. It's not ready, so this cannot be done. Link is enabled. So this basically is a way that you can represent your ability to do a certain action in MTConnect directly to the other machine. And it's a much richer communication than if you're just talking about ones and zeros. So that's our idea. The next step that we want to get into in this whole project is to be able to go to a many-to-many scenario where we have multiple robots, multiple machine tools, and connect them all up together, and then have them communicate with each other and coordinate activities. And the idea is to have these robots and machine tools basically associate themselves dynamically with each other. Instead of having sort of fixed paths and so forth, do it on demand. So as machines are ready, as requests come in, as a robot is ready to, as a machine is ready to do work, as a robot's ready to do work, they can coordinate and prioritize and, again, push the intelligence out to the edges. And we created a bunch of interfaces, the chuck interface, chuck, door, material handler, and bar feeder at this point. And if you look at the way the whole thing works, to walk through it, basically, on the robot side, we have this request response. So the request is down here. Machine tool will go from ready to active, and the robot will be in a ready state. When the machine tool goes to active, meaning that it is requesting something to happen, the robot will then transition to active, saying that is now taking care of that request. Now, if you go to more devices, basically what it does, it says, okay, I am active and I'm working with you. Once the robot has completed that activity, it just goes to complete. So it's a very simple scenario where you just say, active, ready, active, complete means that now I'm done. And then the machine tool will acknowledge by going back to ready, then they go back both to a ready state. That's all it is, really. And the idea behind this is that if you say, like, this is a load material, at the point that it says it's complete, it will say that it has, that means that everything went okay and it's done its job. And the nice thing is that it actually works really well. Like, this is a material load request. When you get to complete, the material's in there, and the machine tool can then make the decision, just go and start working on the material. This is the original, this is the state machine that we used for the demo when we did it, and all the different transitions, and this is why it gets, the implementation is a bit more complicated. But we actually have open source examples of this here. These are all the different states, like door unlatched, door closed, door open, and so forth, and how each one of these transitions will then take it. So when the machine is in any one of these states, basically it's not ready, then how it gets to a ready state. Basically, the other side goes to a ready. If it goes unavailable, it'll go back. When it goes active, this thing goes active. And then there's also a failure state, or it can go to a complete. So basically, this is how it manages states. This is just for a door open. What we actually did, this is up on the internet as well on GitHub, if you want to take a look at it at some point. We have a whole series of tests that will walk through the entire process and show you each one of the states and what the assumed responses are supposed to be. Yeah?
Is that your?
Yeah, it is, yeah. So the thing was written in Ruby. It's a Ruby state machine. So yeah, this is all Gherkin. So that drives some tests, the integration test process. And it will basically say, when the robot material interface, material load becomes active, then material load state should be processing, and the CNC door state should be open, the CNC rotary state should, the and shoulds basically are tests, making sure everything is in the right state at the right time. And then when the robot chuck interface becomes active, then the CNC close chuck should be active. After 1.2 seconds, the CNC close chuck should be complete. These will fire off and basically verify that every single thing is happening properly. It's test the entire state machine. So we wrote this whole thing out to verify it beforehand, and we tested it over at NIST, and worked great. We also have a whole bunch of failure scenarios as well, where, like when the material state load state should be processing, and when the robot chuck interface close becomes active, this becomes active, and the CNC rotary chuck state becomes unlatched, then you go to failure. Close becomes failure. So we tested almost every failure scenario we could possibly think of in this thing. We brought it over to actually test on real equipment. Then we went through the actual physical version of this, and it all worked perfectly. It's amazing. So when you simplify things and you simplify your interfaces to that high level intent, it actually simplifies all these tests as well, to the point that you can recover from almost anything. There's no scenario you can't get out of. And there's a lot of scenarios where the device, like the robot, could fix itself without even involving the machine tool or going into stopping the entire cell, where it would drop the part. We whacked the part out of the robot, and the robot realized it and then failed, but it basically went back and grabbed another part. So it was able to recover and figure it out. Same thing with the machine tool. The machine tool failed, but could still be recoverable. Then the whole thing just kind of worked. So we're trying to get into this many-to-many scenario where we have multiple robots, multiple devices, and then we have material flying all over the place, and that should be fun. So that's kind of, we only took it to a 1-to-1 in the first case of the standard, just to make it easy to test and to verify. But the next phase, we want to get into more complex scenarios with this thing. So one other thing I wanted to talk about, which I forgot to put in my slides, but the other area that we're going to be getting into with respect to, because I was supposed to do security and interfaces. I did security first. The other area of security we want to get into in the standard is we call semantic security. I'm calling semantic security. I'm making up terms again. So semantic security is where we have the ability to express the ACLs, basically, as a set of rules based on the MTConnect model. So you don't have to secure every single data item separately. We can secure groups of data items that are like a certain thing of a certain type, and therefore give a generic type of security across all devices. So I add another device, I don't have to change my whole security profile or reconfigure it. I can basically just have the security, basically the security will flow through. So let's say I don't want to let anybody get any position data or any telemetry. I can remove all the telemetry data. If I want to just give, let's say, basic controller mode and execution, which are two basic things you need for tracking what your machine is doing, to a certain application, I can do that. And we can do that using certs and other things to verify who that person is. Even in the example that I gave you with Proxy Pass, it passes through who the user is. So we can track by user. And the next version of the agent will be implementing some flavor of that. And again, if you put that together with certs and with basic auth even, you have a pretty secure system which actually has a security system that most other standards don't have at this point, or most other systems don't have, because they require more complex security profiles since they don't have a semantic model to leverage off of. So we're going to be leveraging off of the fact that we do have a semantic model to be able to give a new flavor of security that most of the pure communication standards do not have. Yes?
Question on your robot interface. You pull up the traditional interface, pull out the wires, just depended on an Ethernet cable, if I understand right.
This is
Performance did you lose?
none. Actually, I think we gained performance.
Yeah, I remember you were saying that, Neil, and I think that, if I remember correctly, I think Brian Sides was surprised by that, wasn't he?
Yeah. So basically, so when we started this, the fear was when you round tripped, so let's do like a simple state transition here. When we transitioned from, let's say, a ready to active, how long would this take? So the fear was that, okay, if we have to transition the state on the machine and then send that to the agent then has to parse that, turn it into XML, shoot it out the other socket, and get it back to the other device. How long is that going to take? And it's going to be, it's going to be days, obviously. So what we said is, okay, what is our time frame? How long do we have to do that round trip? And pretty much what people told us was it was within a PLC sweep. So my question was, how fast is a PLC sweep? And because that's how fast, if you look at the wiring diagram, that's how fast when one of these wires goes hot, it takes for this guy to realize it. And then people told us, like Neil and everybody was saying, oh yeah, it's usually around like 25 milliseconds. When I heard 25 milliseconds, I was like, oh, wow, we have days. Seriously, I mean, and the fact is that we were then able to test this thing and say, okay, that's why we were talking about the interval 0 before, and Neil brought that up. That's how we created this. It was like, okay, pop it into a high priority thread, and how fast can I move it through? 3 milliseconds, end to end, to be able to do like that type of transition, and way under PLC sweep. So we could actually go faster than the machine could realize on a wired interface. And that was on a reasonable class machine. I did it on a really cheap ARM industrial PC running at like 100 and some odd megahertz. And it was about, I think, 9 milliseconds, 8 milliseconds. So we're still under the PLC sweep rate. And again, that was a complete round trip. That was, basically I used a single adapter that also was using that thing that I showed you, the C streamer. So it was doing the push and the pull. And we timestamped when we sent out the message. Actually, no, I did Ruby. We timestamped when we sent out the message, and then we pulled it back. I parsed it in Ruby, and then checked the timestamps and delted it that way. So I was using a slow interpreted language as well to be able to do the sending and the parsing. But I figured, hey, might as well give it a go. So you can, and I think that's up there somewhere. If it's not, I'll dig it up. But it's, so it's very efficient. Obviously, the certificates and everything will add a little bit of overhead, but if you're using a reasonable class machine in nginx or something like that, the decrypt will be very, very fast. I mean, those libraries have become much more optimal these days. Other questions?
So going forward with the intent-based orchestration, what is it going to take to develop new intents? Is that going to be part of the standard then?
Yeah.
Okay.
They can be extended. There's a section of the standard called interfaces. Under interfaces, you have something called an interface. It has a few data items that are whatever interface, like bar feeder interface, material loader interface, material unloader. And these interfaces are then used to do this coordination. They always have the interface as a suffix. You can put your own in there if you want to as well and extend them. They also have what are called references usually. And a reference is what you need if you're going to be, I don't have an example here right now, I should have brought one up. But you read in the standard, there's something called references. It was added in 1.3. And that allows you from one component to say that these other data items in this other component are important to me. So remember we want to do the interval equals 0, right? So there's data that we need to know when we're doing like a material loader interface. The door, the chuck, states are very important to that interface. Because if the chuck is closed or open in the wrong state when we're trying to do something, we don't want to, we need to know that. So what we do is we allow the device to say that these things are important for this interface in the references. So it references this other area of the model. So if you do the interval equals 0 on that, but say I'm only interested in this interface, it will also pull all the other information from the other areas that you need automatically, and also have that at this super fast speed. And the way it's implemented, for those of you who are sort of more into the tech, it does use conditions. So each data item in the agent is associated with a set of conditions that it's waiting on. So each request has a set of conditions that are then mapped to each one of the data items that will trigger that condition. So when you're waiting in that high priority thread for something to happen, it's not like it's using any CPU. It's not spinning on that. It's just waiting to be signaled. And if it's a decent operating system, it will have priority inversion, in which case things go really snappy. Any other questions?
Well, are there real-life examples of people that are, or customers that are using this today?
No, not yet. I mean, I keep kind of flogging it. We need to get, well, one thing I've talked to NIST a little bit about is trying to get the second phase going. I think there are some people who we could work with. I mean, it takes sort of a combination. So we tried to do an example. I think I talked to Stuart about this a while ago. But then the issue was with one of the Mazacs, but then the issue is basically changing states on those machines. And like I think the way that, Nate, you were doing it, you were having the robot push the button?
At one point, yeah.
Okay. Yeah, so we need to be able to get it to the point where the robots and the machine tools have software in them that are actually actuating this. And that's what I did when I did the test, but I couldn't make it production. So if we could have the builders or somebody who's doing the machine control side of it actually implement that side, then we could start moving this out a bit more. That's been the real problem, is that most people are sort of sticking with the way they're used to doing things, which is through the wiring harnesses. So we need to get beyond the wiring harness and get to the next level. We did some examples. You guys even did at Mazak with LNS. Akuma did it with Edge. So we've tested a lot of this conceptually. The next step is to just really take it and move it to the next level. Other questions? The two-part series, security and security questions?
Yeah, the part Will didn't really bring out was the fact that not only was intent-based orchestration cool, what's really cool is the fact we released it in the standard 2 years before the term was coined.
We didn't use the term.
We didn't use the term, no.
Read, yeah.
We didn't coin it.
Mm-hmm.
All right, we appreciate everybody both coming to the MC² Conference as well as attending the workshops. Very much appreciate it. Look forward to any feedback that you have for us on how to make either of these sessions better. And everybody have a safe trip home.
Yes.
Thanks, Will, for your.
Sure. Thank you, and thanks a lot for staying around this late.